Okay, so here I'm going to do, I was going to do just odd numbers, but I might do most of this first page, and then definitely on this one, I'm just going to do the odd numbers. You do have the answer key for the properties of quadrilateral worksheet, which is the second, third, and then it goes all the way down to 24 total problems, but they go relatively quick. So some of them are super fast. You just have to apply the properties and then you're able to find the missing value, variable, length, or angle, whatever you're looking for there. So here we have a rhombus. I did draw, these are from the notes, so you have these notes that I color coded for you. Before you do these problems, please go through and actually read all of the color codings because they are color coded with the markings on the actual shapes. So please take a bit to read each of those so that you understand what I'm using them for, because we're applying our knowledge of this to the worksheet for today. So it's just a whole bunch of practice, okay? So here we have a rhombus where all of the sides are equal. The sides are also parallel. Looks like I forgot to put that, but the sides are also parallel. Okay. And then they have 90-degree angles all around there. Let me see if this sheet said it here. I don't know if it says it on anything. Bummer. Yeah, because even squares, you know, the opposite sides are parallel. Rectangles are, the opposite sides are parallel. Okay, so mark that up on your practice sheet if you, or just make a note that all these parallelograms there so far, these are all parallelograms because the opposite sides are parallel. So just like these as well. And then for an isosceles trapezoid, the top and the base are, or I guess the top base and the bottom base are parallel. But in a kite, we don't have sides that are parallel there. Okay, and then you can even see like these little summary charts. So it goes like more specific, it looks at the diagonals, whether or not the diagonals bisect, which means that they cut them directly in half. And then here's kind of a chart to show you, you know, which ones branch off of each other, which ones have in common. So definitely look through these notes before you do the worksheet, okay? All right, so for a rhombus, I'm looking at the angles here. It says find the missing angles for number 1. Okay, so if this guy here is 41, it looks like my diagonals bisect the angle, which means that each angle on either side of a diagonal is equal. So if that side is 41, then so is this side. And I like just starting to fill them all in. Okay, and then if this is a rhombus, like it said it is, right? Then the ones across from it, if you look over here, that these here are equal to these here. So that means that if those two are 41, then these two are each 41 as well. So this one is 41 and 41. Okay, so now we also know that this angle is equal to this angle, because if you add those two together, they're going to be the exact same thing because each half is equal. So I know that this angle is equal to this angle. Okay. Also, we can add up these two angles. This is going to be equal to 82 degrees. Okay, and I'm going to move that inside so you know that that's like the measure of that angle there. And then this one is also equal to 82 degrees. So one thing we know is that the area or the angle measurements inside of a four-sided polygon, the angles add to 360. Okay, a triangle they add to 180, a quadrilateral it adds to 360. So here we can find B and C. You could have like looked at them as individual triangles and done add them up to 180. But you could also take the 82 plus 82. So we get 164. Now if we take that away, 360 minus 164, because we need 160, right? So we're left with 196, okay? So now we know that we have B and C. So B and C adds up to equal 196. Now, since these two are equal, right, those two add up to equal 196, they're equal. So let's just replace them with x. This would be 2x equals 196 because, again, they're equal, so they're both equal to x. Divide them by 2. Okay, so here we're going to get 98 degrees. So these are each 98 degrees. And you can always double check this if you use a calculator. You can do 98 plus 98. So let's do it real quick. I won't do this every time, but just for this one. 98 plus 98 plus, oh man, I have the worst memory. I think it was 82 plus 82. Yeah, so they add up to 360 degrees. So you're like, perfect, I'm good to go. The four-sided figure adds up to 360 degrees for the angles inside. So that's awesome. So each of those B and C are 98 degrees. And this is kind of messy. I should have zoomed in more because then I could have written smaller, but I wanted to keep this in the picture for you guys. But you can definitely zoom in to write way smaller than me. But once you're all done, you can write down that A equals 41 degrees, B equals 98 degrees, and C equals 98 degrees. So those are your final answers there. All right, so number 2 is dealing with sides here. So it says find A, B, C, and the perimeter. And again, it's still a rhombus, okay? So now here, it looks like my opposite sides are equal, and in a rhombus, all the sides are equal. All of them, kind of like a square, but a rhombus does not have 4 90-degree angles on the outside interior angles. So this one, we just know all the sides are equal. So I mean, if this is 8 and all the sides are equal, all of these are 8. Okay, pretty quick, right? So the perimeter, you add up all the sides. And I think you can tell me what that is. Okay, so go ahead and solve that. That would be the perimeter. Remember to pause throughout the video. I'm going to go pretty quickly, but please pause throughout the video, okay? All right, so here it says find angle BCE, angle DEC, and AE. So AE is a side. That's why that's a side there. Okay, so my angle, all I have so far is this 59 degrees. Okay. We are asked to find BCE, so I'm going to go and mark that. So BCE, so it's going to be this angle right here. And I'm going to erase those ugly lines. That's the angle BCE. Angle DEC, I follow from DE to C. So it's going to be this angle right here, which actually is a 90-degree angle. So we know that one right away. That's really nice. So I know that that's 90 degrees by definition of a rhombus, where the diagonals bisect each other. They create 90-degree angles there. So they are all perpendicular. Okay. So now I know angle DEC is 90 degrees. I want to know side length AE. Okay, so let me assign a color to that guy, AE. All right, so that is side length AE. I'm going to actually highlight this one so you don't think like you put a line underneath the lines. You don't. Okay, so AE is that one. And looking here, so this is a diagonal. So this whole piece here, this is a diagonal. And this is the other diagonal of the rhombus. So we could like turn this rhombus over to have it look more like that one. Just know that those two are diagonals. So looking at my rules for my diagonals here, what do you notice about each half of the diagonal? They're marked as equal. So the diagonals bisect each other, which means they cut each other equally in half. So if this side over here is 12, if CE is 12, then AE is also 12. So AE equals 12. So this is really just applying because if this is 12, this is equal to that, just like that one would be equal to that one. Okay? Does not mean that they're all 12. It's just the ones that are bisected. Okay, so that one is bisected. We know one side is 12, the other is 12. All right, so we also have to find BCE. Well, okay. Oh, I like this one. So we have a triangle here, and we're wanting to find that orange angle, right? Gosh, that was a horrible line. Okay, not much better, but whatever. We know that at the intersection, we have 90-degree angles. Okay, we can ignore this 12 here. That was the side length. So now we have this triangle where we have 59 degrees top left, a 90-degree angle here, and this missing angle here. So we know that a triangle adds to 180 degrees. So we have a 90, the green one there, and we have a 59. So that's 149. So to figure out the orange, we do 180 minus 149, 31 degrees. Okay? So these are literally just like punching in the numbers, making sure that you understand, just all of these different properties of this particular quadrilateral. Okay? Don't forget that you still have to find the perimeter all by yourself. And you guys have to show all of your work. Otherwise, I'm just going to assume that you like look at these and just copy them because you have to show all of your work. Like I can't even just do everything in my head. You need to show every single bit of work. All right, so number 4 gives you different pieces. Now I'm going to remind you, it looks like we're using the diagonals here. So what I'll do here is I'm going to mark these up so I can write a little bit smaller. So this is a diagonal here. And this is the other diagonal. We know that the diagonals bisect each other, so this half of the orange equals this half of the orange, and this half of the green equals that half of the green. All right? So they tell us that the side RK, which RK is right here, this is the side RK, or the segment RK, they say it's 5. And then KY is 12. So now it says to find the perimeter. Ooh, this one's nice. I like this one a lot. I sound like such a nerd. Okay, so here again, we want to look at the triangle itself. We know that in the middle there, it creates a 90-degree angle right there. So in order to find the perimeter, we know that these on the outside are all equal to each other. If you look at the definition again, all the outsides are equal. So we just need to find one side and then we add those together 4 times to get the perimeter. Okay, but first we need to know this side. We don't know it. However, let me redraw this. So I'm going to redraw this off to the side here, that one triangle there. Okay, totally not drawn to scale, mind you. It's totally not drawn to scale. It's horrible. So this is the side, this would be the R, and that's side length 5. This is the K here. And then this is the Y, and this is side length 12. Okay. I'm going to actually not write those in those colors so you don't think. So these are just the corners here that are helping me name my triangle. So I have a triangle RKY. It was literally just this triangle here that I pulled so you could see it set up like a right triangle. We know a little fancy thing called the Pythagorean theorem that will help us solve for that missing side there. Okay, so we label the legs A and B and the hypotenuse C. A squared plus B squared equals C squared. Again, please pause the video and do this yourself. Give it a shot. So A is 5, and then B is 12. This one's a nice little Pythagorean triple, if you remember that. That's what we call this. C, I'm just going to replace with X. The C is just really the part of my formula. So 5 squared is 25, plus 12 squared is 144 equals X squared. 25 plus 144 is 169 equals X squared. Take the square root. We don't need the plus or minus here because there's no way we can have a negative side length, right? It's not possible. So we just leave it as a positive 13. So now I know that my outsides are 13, but for the perimeter, you have to add that 13 together 4 times, or you could just multiply by 4. But you need to find the perimeter. Okay, make sure you do that. I know some of you might just be watching me do it and copying down what I do, but you really won't learn as efficiently that way. You really need to take a step back and pause the video and try the problem on your own first once I get you started, okay? All right, so number 5. So we're talking about SP. So first I'm just going to identify what I have going on here. So we have SP and then PQ. And again, guys, with the rhombus, if you look back up at our little picture, we know all the outsides are equal to each other. Okay, all the sides are equal. So they told us that SP is 4x minus 3. So this side length is 4x minus 3. And then they said PQ is 18 plus x. It says find x. Well, if we know they're equal to each other, you can simply set up an equation. So we have 4x minus 3 equals 18 plus x. You should definitely know how to solve for x. Okay? Go for it. You got it. Solve for x, and then you're done with that one. Okay? It's really just knowing, like, what do I need to do given that this is a rhombus? So we're still in the rhombus section. Numbers 1 through 6 are all rhombus. Next will be square. All right. So if measure angle ADC equals 3x plus 6, well, let's go ahead and mark this guy. I always mark right away. So ADC is that big angle right there in the corner. Okay, so I'm going to mark it like this because you go from A to D to C, and it makes that angle right there. Okay, sorry, my chair is very loud. Okay, and then the measure of angle EDC, so I have EDC. Okay, so it's just half of that angle here. So EDC is just half of it there. Find the measure of angle EDC. Okay, so we know if we go back up to our little rhombus here, we know that the diagonals cut these angles directly in half. All right, so this gives us the opportunity to write an equation. So that green angle there is half of the orange angle. So we could always set up an equation. You can also think of it as 2 times the green angle, which is 2x minus 5, is equal to the orange angle. Because 2 times that one, right? Because it would be 2x minus 5 times 2x minus 5. Or I'm sorry, plus 2x minus 5. So you could even write it as 2x minus 5 plus 2x minus 5. That would be the same thing as multiplying 2x minus 5 times 2. Exact same thing. You'll get the same answer. But regardless, this is equal to 3x plus 6. And now we have to do this because we're trying to solve for x, so then we can plug in x into this equation here to get our angle EDC. So we're trying to find the measure of this angle right here, just half of it, half of that orange one, okay? So we want to solve for x. And I'm going to leave that there just so you guys can see, like, if I distributed it or if I just combine like terms, 2 times 2x is the same as 2x plus 2x is 4x. 2 times negative 5 is negative 10, which is the same thing as negative 5 minus 5, which is negative 10. Okay. So I'm going to leave the rest of it up to you guys. You need to solve for x. Then plug x into the 2x minus 5. Sorry, my hair is kind of sloppy. To solve for the measure of angle EDC. Okay, so your goal right now is to solve for x. All right, you can do that. I know you can. And then plug x into 2x minus 5. So you replace that x with whatever you find. and that should be the measurement of angle EDC. Okay, pause the video and do that. If you just write this down, you will not get credit. Okay, so you need to actually do the problem. All right, I'm just trying to guide you here. Okay, so here we have a square. Okay, did I put that? There it is. So let's just remind ourselves, a square, there's a lot of right angles. So there's 4 right angles along the interior of the square. And where the diagonals bisect each other here in the middle, more right angles because they're perpendicular. All of the diagonals are equal to each other. Therefore, whenever they're bisected, all of their halves are also equal to each other. And also, all the sides of a square are equal to each other. Okay? Also, the diagonals bisect these 90-degree angles directly in half. So that means that all of these guys in here are 45-degree angles because they are cut perfectly in half. You can see with the little dash mark that means that they're each equal to each other here and here. So they are all 45-degree angles because that is half of the 90-degree angle that we have there. Okay, so that's super important. So I'm going to go and take a peek at what problems we have here. The first one is find the angle ABE. So ABE will be this angle right here. That's angle ABE. And CEB. So CEB is this angle right here. So I want you guys to use your diagram. The measure of angle ABE equals what? You just really have to look at that color diagram down below. Measure of angle CEB. I did not draw the curved to trick you, but I'll tell you that the perpendiculars there means that they're 90-degree angles. Okay, but you can find ABE because we literally just talked about it. All right, so here I have the measure of angle MHK is 5x minus 10. All right, so MHK is 5x minus 10. MHK. So solve for x. Well, what does that measure angle MHK equal? What does that equal? If you look down here, right, look down below here. Each of those that are bisected by the diagonals are 45 degrees. So to solve for x, you can write 5x minus 10 equals 45 degrees. And I know that you guys are more than capable of solving for x there. So go ahead and solve for x, and then that problem is all done. It does not ask you anything else besides to solve for x. Okay? All right, here we have PQ is 9 centimeters. So let's see here. PQ is 9 centimeters. We'll just put a 9 there. They want to know what MQ is. Okay, well, if you notice here, we do have a right angle here. So there's a right triangle. And we know that all the sides of a square are equal. So this side up here is 9. So now all we need to find is this side NQ. So again, I'm just going to kind of pull that out here. So I'm going to leave it oriented the same way, but I'm just going to write it over here. So we have these two sides that are each 9. And then we have this missing side, the hypotenuse, I'll call X. This is the NQ here. That's the side we're solving for. Okay, so we have NQ and we have this triangle PNQ. And this is a right triangle. So again, with Pythagorean theorem, your legs are A and B. So A, B, and then your hypotenuse is C. So now we can just replace with what we have. We know the A is 9 and the B is 9. Right, so we have 9 squared plus 9 squared equals, and then we'll use x for our missing side here. Okay, so this is 81 plus 81 equals x squared. So this will be 162 equals x squared. You take the square root of both sides, you are going to get a decimal, and that's fine. You'll say x is about equal to blank. So that is the side of NQ. You'll say NQ is about equal to blank. Okay? And it's fine if it's a decimal, just round it to the nearest hundredths place. All right. Oh, this one's not too bad. Okay. So here we know if RS, so we know all the sides of a square are equal, correct? So keep that in mind. All the sides of a square are equal. So, different color than up top. Sorry, guys. Blue. Okay. RS equals 3x plus 7. Okay. And ST equals x plus 34. We're asked to find the perimeter, but first we need to solve for x. That's the first thing. One thing that's nice is that we know that all the sides are equal. So we know that x plus 34 is equal to the 3x plus 7. Okay, so now if we solve for x, make sure you guys are pausing again. Sorry, I keep forgetting to remind you, but I hope that you are pausing and doing these on your own, okay? So we have 34 equals 2x plus 7. Also, since I'm going so fast, make sure I'm not making any mistakes. 34 minus 7 is 27 equals 2x. Divide both sides by 2. I'm going to get x equals 13.5. Okay. So now that we know x, we can plug it into either of these. I mean, it doesn't really matter because they should be equal no matter what, right? So even if I did 13.5 times 3, I get 51014. So 40.5 plus 7. Careful with that decimal placement. So I got 47.5. I should get the exact same thing here if I did 13.5 plus 34. Yep, that should be 47.5. That was a horrible 7. 47.5. So there's four sides of a square that are all equal. I could add 47.5 to itself 4 times, or I just know the perimeter is 4 sides times 47.5. So find the perimeter. That's just all the outsides of the square. And again, since all the sides are equal, you can just multiply it by 4 because there's 4 sides. All right. Whew, okay. Now I'm only going to do the odds, okay? Hopefully I can get through all 12 odds. So do your absolute best, complete all of these problems. You will be tested on this for the chapter 7 and 8 quiz, or test, it's an exam. So I'm just going to do all the odd problems. So this is just a four-sided, it's not a parallelogram, sorry, I almost said that. It is a quadrilateral, which just means it has 4 sides. One thing with the quadrilateral is that they all need to add up to 360 degrees regarding the angles. All those angles must add up to 360 degrees, okay? So we have an angle that's 120, 64, and 94. So again, you guys can definitely use a calculator, but just for quickness and me not having to switch back and forth and wait for them to load, I'm just going to add mine up here and hope that I do all my math right. So now if all those 3 add up to 278, I can find my missing one by subtracting 278 from 360. Okay, so it should be 282. Answer should be D. And I can check my answers at the end as well. Just like you guys should be, okay, as you go through. I don't want to make you like motion sickness by me flipping back and forth through the answers though, so I'll check them after. All right. Solve for x. All right, cool. So we know that all the angles inside of a quadrilateral add up to add up to 360. So I can set up an equation. I have 11x plus 5 plus 70 plus 88 plus 120 equals 360. And now I can solve. Okay, so first of all, I'm going to combine 5 plus 70 is 75, plus 120 is 195, plus 88. I just did that because it's faster. 18, 283. Okay. And my goodness, I hope I'm doing all my math right now. It's pretty late. 11:27, that's late for me, probably not too late for you guys, but all right. So I'm going to subtract 283 from both sides. I need to get better at like using a calculator off to the side while I'm making these videos. But since the iPad stopped letting me do the split screen while I'm recording, I really miss that split screen. I could just have the, the camera right, or the calculator right there. All right, now divide both sides by 11, and that works out nicely. So I'm going to assume I did all my calculations right. So it did just say solve for x. Sometimes it'll say to solve for a specific angle, so you want to be careful and make sure you're plugging that back in instead of just solving, for x. But this one is D. Make sure you're pausing, okay, and trying out these problems on your own as well. All right, so number 5. Okay, it says find the measure of each angle indicated. So this time it's telling you we want the measure of angle U. So I want to know what this angle is going to equal, but I'm missing the x there, so I really need to find the x. Now it says, let's see here, does it say if it's, oh, it does not. That's a bummer. It looks like a parallelogram, but since there's no arrows indicating that it is, we cannot assume. If it was actually a parallelogram, it would be a lot easier because like the adjacent angles add up to 180 if it's a parallelogram, but not if it's not. So like all these angles, like, let me show you. So those top two, these two add up to 180. Oh, these two do add up to 180. So that's nice, but I don't know that that can guarantee, if we don't have those parallel sides here, we cannot absolutely guarantee that just because these two add up to 180, these two will, these two will, and these two will. We cannot guarantee that without those parallel sides, okay? So we don't know, but we do know that they all add up to 360, okay? So we can write 37x minus 1 plus 70 plus 110 plus 24x minus 2 equals 360. Whew. Just combine all your like terms first. Okay, so I have 37x into 24x, and then all the rest of them do not have x's, but we can combine all of those constants there. So 37x plus 24x, this should be 61x. Okay. I always do 30 plus 20 is 50, 7 plus 4 is 11, so 50 plus 11 is 61. All right, so here I like to add like these two together first. 70 plus 110 is 180, minus 1 is 179, minus 2 is 177, equals 360. Some of my mental math there for you. All right, so now I'm going to subtract 177 from both sides. Okay, 10 minus 7 is 3, 15 minus 7 is 8, 2 minus 1 is 1. So I'm left with 61x equals 183. This one's nice too. If you divide both sides by 61, you should get x equals 3. And again, I'm purposely moving fast to try to slim down the length of this video. So I still am not done though. Okay, you're lucky that 3 is not an answer choice here, so it doesn't really trick you. But we're asked to find the measure of angle U. We know that angle U is 37x minus 1, and we just solved for x. Okay, over here, we just got that x equals 3. All right, so we want to do 37 times 3 minus 1. So 30, again, please use your calculator, it's faster. I'm just doing this because I can do this relatively quick in the video. 9 plus 2 is 11, so this is 111 minus 1, 110. Ah, so this one was a quadrilateral actually, because if you see, or I'm sorry, it's a quadrilateral, but it's a parallelogram as well. Because if that's 110 and that's 110 and that's 70, then this one must also be 70 in order for them to all add up to 360. Interesting. Okay, So these are the types of connections I want you to start realizing. It's like, oh, it is a parallelogram, but I couldn't prove it before, right? First, you had to find those other angles. All right, because you'll notice over here, it's just a quadrilateral. So this one is kind of crazy, but you still set it up the same. So you're still trying to find, like this one is the measure of angle U. But first, you want to add all of those up. And it does seem like a lot, but you can totally do it. You just have to combine your like terms. 14x plus 2. So all those angle measurements, you know, add up to 360. So have fun combining like terms. You solve for x, and then you plug it into the measure of angle u to get the measure of angle u. Be careful with your adding, subtracting, multiplying, all that good stuff. Use your calculator to check your answers. Okay. So now it's like, yep, for sure it's a parallelogram. So if we know it's a parallelogram, all of these things here hold true. Okay, so the adjacent angles add up to 180. The same thing works for square, rectangle, I believe a trapezoid as well, a rhombus, you know, so a lot of the quadrilaterals it does work if it's a specific quadrilateral. Okay, not all of quadrilaterals. But this one is special, it's a parallelogram. So also the opposite sides are parallel, just like I said, I totally forgot to put those arrows on there, but parallelogram, opposite sides are parallel. So over here, we're given two adjacent angles. So it's like we're given these two, right? We know that adding them together gives us 180. So here we're asked to solve for x specifically. So I know that angle R plus angle Q will give me 180 degrees. Okay, that's what I pulled from my little drawing over there. And I know that angle R is 5x plus 10, and angle Q is 110 degrees. And those two add up to 180. So now I know that I can combine like terms and solve for x. And then that'll give me the answer because it only asks me to solve for x here. That's it. It doesn't ask me for the actual measurement. But if you were to want to figure it out, you could even set up an equation that says 5x plus 10 equals 70, because 110 plus 70 is 180, and those two add up to 180. So, but that's basically what we're doing here. So 10 plus 110 is 120. Bring down that 5x, 180. So now we can subtract both sides by 120. Okay, so now we have 5x equals 60. Divide both sides by 5, x equals 12. And this answer is D. Okay, so apply the same knowledge to number 8. Remember, if it's a square, that means it's 90 degrees. Okay? Or if it's like this right angle, that means it's 90 degrees. So that is just a parallelogram. It looks like it's also a rectangle, right? Because the 90 degrees. But we don't know everything about the sides. But we know enough about the angles to where we know the angles are 90 degrees each, if one of them is. Okay? Because these two would add up to 180. The only way they could do that is if this guy was also 90. Same thing here, they need to add up to 180 if it's a parallelogram. So this guy must also be 90, and same thing here. So I mean, you could just set 13 plus 11x equal to 90, or you can do 90 plus 13 plus 11x equals 180. Totally up to you how you want to solve that one. You should get the same answer either way. So this one is still just solving for x. Solve for x. Same instructions as here. Okay? Make sure you're pausing the video and actually doing those problems. You can always finish the rest for homework. The Khan Academy today is pretty easy. All right. Same, parallelogram still. Okay, same thing. So we know that the opposite sides are equal. All right, so if we're solving for x, we have 2x minus 16 equals 6. Add 16 to both sides. 2x equals 22. Divide both sides by 2. X equals 11. Bam. So you're just using the knowledge. If that's a parallelogram, the opposite sides are equal, you're given those two opposite sides. So always look at what I'm given and then go from there. Same thing here, parallelogram. So these two sides are equal, solve for x. Set up your own equation. All right, here's parallelogram again. All right, now it's getting more specific. You solve for x and then you find the measure of a side. Okay, so it says here, find LK. LK is this top side here. So I know it's 9x, right? But that doesn't give me enough info. I need to know what x is. But I do know that this side LK is equal to this side MJ. So this is equal to 2 plus 8x. And now I can solve for x. Okay, so if I solve for x, I'm going to subtract each side by 8x. And if you want, you can always draw that line of equality, right, down the equal sign. Here it's pretty short actually, so I'm going to get 9x minus 8x is just 1x equals 2. All right, so again, that's not enough to find LK. LK equals 9x. And so LK equals 9, and we know x is 2. So LK equals 9 times 2, 18. A. All right. Same thing for number 12, okay? So use your same knowledge. These sides here are equal. It's asking you to find the side ED. So use the same method. We solve for x, and then we solve for the side measurement, okay? Go for it. All right, number 13, okay? So this, again, is a parallelogram. I think I'm going to copy this image again, though. So this image here, I keep cutting off that 180. Copy. All right, just so that we have it as reference right here, during the video at least. Okay, so it says LS is 2x minus 12. So LS is half of a diagonal. LS is right here. That's what LS is. Okay, and it says SN is x. So SN is the other half of that same diagonal. That's convenient. Okay, so here what we know is the halves of the diagonal are equal to each other because the diagonals bisect each other. So this side equals that side. So we know they're equal to each other. So we can set up, so we know LS is equal to SN. And SN is x, and LS is 2x minus 12. Okay? So you can do this several ways. I'm going to subtract my x first. And this might seem kind of weird because now there's nothing here, but you just put a 0 there. So now we have 2x minus x is 1x minus 12. X minus 12 equals 0. So we can add 12 to both sides. And we're going to get x equals 12. You could have also added the 12 over and then subtracted the x. That would have been fine too. So I want to show you what that would look like. Just in case you were like, wait, what? But regardless, so we could have added 12 to both sides. 2x equals x plus 12. Subtract x, x equals 12. You could have also subtracted the 2x over and then divide both sides by a -1. So whatever way you do it, go for it. All right, so we know x equals 12, but that's not what it wants us to do. It wants us to find ln. Okay, so now ln is the entire side. A little tricky, right? So if we know that x equals 12, right? So if Sn is just x, then we know that's equal to 12, and this would be 12 then. And if you don't believe me, you can plug it into 2x minus 12. So the 2x minus 12 is the LS. If you do 2 times 12 minus 12, that is 24 minus 12, which is 12. So each of these sides here are 12, or each of the halves of the diagonals. So 12 plus 12, 24. ln equals 24. ln is the entire side, the entire diagonal. You can tell I'm getting faster because I'm getting really tired. So please make sure that you're pausing the video, okay? Use the same logic. Here you're working with DJ and JF, okay? And it wants you to find DJ. You got this, go ahead. All right, so now we have a trapezoid. So this one is asking us to find the median. The median is that middle line right here across the middle of the trapezoid. So we have a formula. The median of a trapezoid is equal to 1/2 times the base plus the base. So that basically means like base A plus base B. So if you want, I can go ahead and put just like an A and a B here. So then another way to rewrite a median, you can write A plus B, and 1/2 of that would be divided by 2. So if that's a little bit easier, that's totally fine. Go for it. So this one, top base is A at 5.7, bottom base is B, 19.9. Multiplying by 1/2 is the same as dividing by 2. Okay. I just really do not want to butcher this in my head. It's too late. So 25.6. So we're going to have that the median is 25.6 divided by 2. I'm going to definitely do long division here. 1, 2, 5, 2, 4, 1, 6, 8. 12.8. So our median length there, that line down the middle there, is 12.8. So we just solved for WX. 12.8. So you just have to use a formula for that one, guys. Okay? Lucky you don't have decimals in this one. So it should be pretty quick. All right, so find the median. All right, so these are trapezoids again. Now this one looks like a rectangle, but you see here it's 85 degrees, so it is not. But one thing we do know about trapezoids here, so if I were to, let me see here. Well, I can't really take an image of that. There are some things I can't move. But this one also has where these two angles add up to 180 degrees in a trapezoid. Okay? So here, if I'm given like those two here, I know they need to add up to equal 180 degrees. So if I make this an x or something, right? X plus 85 equals 180. Well, what's x need to be? Subtract 85 from both sides to figure that out. You're going to get x equals 95 degrees. B. This one, these two are always equal. So if this one's x, then that one's x. And if this one here is 55, then this one here is 55. So you'll just do the exact same thing I did here. Okay, x plus 55 equals 180. They're supplementary. All right, so here again, we know that these two add up to 180. So if this top guy is 90 degrees, you can either subtract 180 minus 90, but I think many of you know 90 plus 90 is 180. So that question mark there must be 90 degrees. You just have a similar one right here. So you should get that one. Still show some work, all right? Still show some work, even if you know it. Show your work. Show me how you know it. Whew, all right. So once again, these two add up to 180 degrees. The reason why there's so many problems, guys, is because this is pretty much the only day I can spend on this given the block schedule and everything. So I figured, I was like, okay, I'll take the notes for them. They can refer to the pictures and then apply their knowledge to these problems. So we have to find the measure of angle M. That's our end goal, okay? Our end game. So that is angle M. But first we have to solve for x. We know that in trapezoids, those adjacent angles there add up together to equal 180 degrees. So I'm just adding them together to equal 180. And now I need to solve for x. 77x plus 106x. 183x. Negative 2 minus 1 is negative 3. That worked out nicely. Add 3 to both sides. We get 183x equals 183. Divide both sides by 183. x equals 1. But that's not our answer, right? If x equals 1 and measure of angle M is 77x minus 2, we have to plug in a 1 here for x. That's going to be 77 minus 2, 75 degrees. C. So now you can do the exact same thing with number 22. So again, remember to pause. I'm going super fast, so remember to pause and try things on your own first, and then watch how I solve them to check your work. The median. So again, I'll write down the little formula. I just write like an A and a B, A and a B. The median is half of A plus B. Should be 2. Okay, so that's for the median, and the median is just that line down the middle here and here. Okay, so this one says find the median of each trapezoid. Okay, so the median is equal to 8x plus 2. This one gets a little bit tricky. So 8x plus 2 here is the median. So I'm going to write that down. The median is 8x plus 2. And I know that the median is equal to A plus B divided by 2. Okay, so this one gets a little bit tricky, but nothing you guys can't handle. So we have 9x minus 8. And then plus 33. That's your B. Okay, and now we solve for x. All right, because it wants to tell us what the median is, or it wants us to tell them what the median is. We need x before we can find the median. Okay, so here I would first multiply both sides by 2 to get rid of that fraction. All right, so really what I should have written is like this in parentheses times 2, because that 2 needs to be distributed if you're multiplying both sides by it. So now I'm going to have as 16x plus 4 equals 9x, and then negative 8 plus 33, that's just a positive 25. So now this is way more manageable, right? Hopefully not as scary. Now we have to solve for x. So first I'm going to subtract 9x from both sides. We have 7x plus 4 equals 25. Now we need to subtract each side by 4. 7x equals 21. Divide both sides by 7. We get x equals 3. So now we can plug that into our median. Instead of x there, we're going to put a 3. 8 times 3 is 24, plus 2 is 26. It's C. Okay, so follow the same method, the same idea for number 24. All right, so what I would do if I were you is like have this and just follow what I did where I replace things with the name, okay? Or I replace things with the expression it gave me. Oh, phew, that's 24. Okay, cool. So we can check our answers here. Feel free to check my answers. I'm hoping they're all right since it was right there in front of me each time. Check your answers once you do each problem. So try to do like one problem, check your answer, fix it if it's wrong, figure out what you did. Make sure that you ask the sub for help. He can definitely